Hey everyone, and welcome back for another deep dive. Today, we're going super small, like really small. We're talking nano world. We're going to be looking at how scientists are kind of blurring the lines between biology and technology. And
Yeah, it's pretty incredible.
yeah, for this deep dive, we've got this super interesting article from Washington State University.
Okay.
It's from November 22nd, 2024. And get this, the title is Ion Superhighways. The nanotech breakthrough powering tomorrow's tech.
Catchy.
I know, right? So basically, researchers have found a way to make these things called ions move way faster than they ever thought possible.
And that's a big deal because...
Huge, because they could like totally change everything, like how we charge our phones. And
Yeah, and how we understand the human brain.
it's mind-blowing.
Yeah, so this research is really tackling a big problem in this field called organic ion electronic conductors.
Okay.
And basically these are materials that can use like both ions and electrons to communicate.
So they can speak the language of like living systems and electronics.
Exactly, like a universal translator.
Yeah, I like that. That sounds super promising. So what's the problem?
Well, up until now, the way ions moved in these materials, it was like trying to drive a Ferrari down a tiny little dirt road.
Oh, I see. So all that potential, but nowhere to go fast.
Right. The speed was holding everything back.
So how did they fix it? How did they build that ion superhighway?
They took inspiration from nature.
Oh, cool.
Yeah. Our cells, they use ion channels to move things around really efficiently. And the researchers, they just copied that.
Makes sense.
They basically built these dedicated nanochannels inside the materials, like little express lanes just for ions.
So like an ion-only lane.
Pretty much.
Yeah.
And the result, they made the ions go 10 times faster.
Wow. 10 times. It's got to be some kind of record, right?
It's a new world record.
That's amazing. But how do they actually make these nanochannels work? Like, what's the secret sauce?
Okay, so it's all about molecular engineering.
Okay.
The researchers, they line these tiny channels with molecules that can either attract or repel ions that are dissolved in water.
Which is called?
The electrolyte.
All right, so the water is like the road, and the ions are the cars.
Yeah, and some of these molecules are hydrophilic.
Hydrophilic, meaning?
It means they love water, so they attract the water in the ions in it.
Gotcha.
And then other molecules are hydrophobic.
Okay, those are the ones that hate water, right?
Exactly. And they actually force those ions to take a detour, kind of like a molecular traffic signal.
So it's like, ions welcome this way.
Yeah.
Or detour ahead, use slow lane.
Haha, exactly. And by putting these hydrophilic and hydrophobic molecules in the right spots, scientists can basically switch the ion flow on and off.
Wow, that's amazing. So they can control where the ions go.
Yep. And that's a huge deal because it opens up so many possibilities.
Okay, so it's cool science, but how does this actually help us, like in the real world?
Well, the team actually built a sensor that can detect chemical reactions happening near the nanochannel.
Okay.
So imagine this reaction happens, and it triggers the ion superhighway to either open or close, and this creates an electrical pulse that we can detect.
So they basically turn the channel into a tiny little sensor.
A super sensitive sensor that can detect reactions at the molecular level.
That's incredible. So where could we use something like that?
Oh man, the possibilities are endless. Think about things like pollution monitoring at like the tiniest level you could get real-time data on the environment.
That would be a game changer. And what about healthcare?
Oh, that's where it gets even more interesting. Imagine tiny little sensors inside your body monitoring your health 24/7.
Like a tiny little doctor keeping an eye on everything.
Exactly. They could detect diseases before you even have symptoms or track how well your medications are working.
Wow. It's like having a microscopic checkup all the time.
Pretty much.
But with all that amazing potential, doesn't it also seem kind of risky? Like, what about our privacy?
You're absolutely right. Anytime you're collecting personal data, especially health data, you have to be super careful about who has access to it and how it's used.
It's not just about our physical health, but our digital privacy too.
Exactly.
So it seems like we're learning to control the flow of ions at the nanoscale, kind of like how we manage traffic flow on our highways.
It's a good analogy. And just like we have traffic laws and regulations to keep things safe and efficient, we need to develop some rules for this new nanotech world.
Makes sense.
Yeah.
So as we go deeper into this nano world, we need to be both excited and cautious.
Definitely this technology could change our lives for the better, but we have to be mindful of the potential downsides too.
Well, we've just scratched the surface here, but there's so much more to explore. Stay tuned as we continue our deep dive into the amazing world of ion superhighways.
It's going to be a wild ride.
Okay, so we're back, and I'm like still trying to wrap my head around all the possibilities these ion superhighways could open up.
Yeah, it's pretty mind-blowing.
Like we talked about everything from the environment to healthcare. It seems like this tech could touch just about every part of our lives.
You're right about that. Fundamental breakthroughs like this, they tend to have a ripple effect across many different areas.
Okay.
Like think about energy storage, for example.
Well, yeah, batteries.
Exactly. Imagine charging your phone in just minutes, or electric cars that can go like hundreds of miles on one super fast charge.
Yeah. No more range anxiety.
No more being tethered to a charging station for hours.
That would be awesome.
Right. And this tech could make it happen because faster ion transport is like the key to both charging and discharging batteries quickly.
Oh, okay.
And it's not just about speed either. We're also talking about higher energy density. It
Meaning?
means batteries that can store more power in a smaller package.
So smaller, lighter, and faster charging batteries. Sign me up.
Well, the research is definitely promising. But let's move beyond batteries for a second and go back to that sensor we talked about.
Okay, the one that can detect chemical reactions.
Right. Remember, it works by sensing those tiny changes in ion flow caused by reactions happening nearby.
Right, so it's like a super sensitive nose.
Yeah, exactly. And this is just the beginning of what we could do with biosensing.
Oh, this is the healthcare stuff, right?
Yeah, I think we just scratched the surface earlier. I want to dive a little deeper into how this tech could revolutionize the way we monitor and manage our health.
I'm all ears.
So imagine a world with tiny implantable sensors that constantly track your vital signs.
Okay.
And they could alert you to potential problems before you even notice any symptoms.
That would be incredible. No more surprise diagnoses.
Right. We could catch diseases early, track how well medications are working, even monitor the delicate balance of neurochemicals in the brain.
It's like having personalized medicine taken to a whole new level.
Exactly. Instead of waiting for symptoms or going for occasional checkups, we have this constant stream of data about what's happening inside our bodies.
Wow. And since these sensors are so tiny, they can probably detect things that regular tests miss, right?
Absolutely. They operate at the nanoscale, so they offer a level of detail and sensitivity that we've never seen before.
It's like having a whole team of microscopic doctors on the lookout 24/7.
I like that analogy.
But hold on, all this constant monitoring, wouldn't that raise some privacy concerns? Like, who has access to all this data?
You're right to ask that any technology that collects personal data, especially sensitive stuff like health information, needs to be handled with extreme care.
So it's not just about protecting our physical health, but our digital privacy, too.
Exactly.
You know, it's interesting. We're talking about controlling the flow of ions at the nanoscale. And it kind of reminds me of how we manage traffic on our highways.
That's a great observation. And just like we have rules and regulations to keep traffic flowing smoothly and safely, we need to develop ethical frameworks and guidelines for this new nanotech world.
So we need, like, nano traffic cops.
Something like that. We need to make sure this technology is used responsibly and for the benefit of everyone.
It sounds like we're not just building new technology, but a whole new way of thinking about our relationship with it.
That's a good point. It's not just about gadgets and gizmos. It's about how we understand ourselves and our place in the world.
It's pretty neat stuff.
It is, and we haven't even touched on one of the most mind-blowing possibilities, neuromorphic computing. It's basically about creating computer systems that mimic the structure and function of the human brain.
Whoa, so we're talking like real artificial intelligence.
Exactly, machines that can learn and adapt like we do.
That's kind of scary.
It's definitely both exciting and a little daunting.
So how would ion superhighways play into that?
Well, by controlling ion movement with such precision, we could actually build artificial synapses and neurons, the building blocks of a synthetic brain.
You're saying we could actually build a brain.
Well, that's a long-term goal, but we're still in the early stages. But even being able to create more brain-like computer systems could lead to huge advancements in AI machine learning, even our understanding of consciousness itself.
Wow, that's heavy stuff.
Yeah.
We've gone from faster charging batteries to artificial brains in like an hour.
It's amazing how quickly this technology is developing and how much potential it has.
But it also seems like there's a lot we still need to figure out and consider.
Absolutely. That's the nature of scientific exploration. We uncover new knowledge, develop new technologies, and then we face new questions and challenges.
So what's next? Where do we go from here?
Well, in the final part of our deep dive, we're going to explore the ethical and societal implications of ion superhighways in more detail.
Okay, so we'll talk about what happens when we blur the lines between biology and technology and what we can do to make sure these advancements benefit all of humanity.
Exactly. It's a conversation we need to have now before this technology gets too far ahead of us.
And we're back for the final part of our deep dive into the world of ion superhighways. We've talked about the science, the potential, and now it's time to get real and talk about, the ethical stuff.
We have a big question.
Right, like it's not just about what we could do with this tech, but what we should do.
Exactly. We're talking about manipulating the very building blocks of life. So we got to be super careful.
Okay, so we've already touched on some of this, like the privacy concerns with those implantable sensors, but I want to zoom out and look at the bigger picture. What kind of world are we creating here? Like when we start blurring the lines between biology and tech, it's like something out of a sci-fi movie.
Yeah, it is like science fiction is becoming reality.
I know. Imagine enhancing our brains, repairing organs with nanoscale precision, or even connecting our minds to machines.
It's both exciting and kind of scary, right?
Totally. Like we could cure diseases, live longer. Push the limits of what it means to be human.
But there's always a but.
Right, like what if this tech gets into the wrong hands? Or what if there are unintended consequences that we haven't even thought of yet?
That's why it's so important to have these conversations now while we're still in the early stages. We have a chance to shape how this technology develops.
Okay, so where do we even begin? It just seems so overwhelming.
Well, I think one of the most important things is transparency.
Like being open about what we're doing.
Exactly. The research, the development, the applications, it should all be open to public scrutiny. We need to demystify the science and get everyone talking about the potential benefits and risks.
Okay, transparency is a good start, but what about access? Who gets to benefit from this technology? Will it be available to everyone, or will it just make the rich richer and the poor poorer?
That's a huge concern. We need to make sure that the benefits of this technology are shared widely, that everyone has a chance to participate in this new era.
So it's not just about the tech itself, it's about building a more just and equitable society alongside it.
Exactly. It's about creating a future where everyone can thrive.
It's pretty amazing to think that we're not just talking about gadgets and gizmos here. We're talking about the future of humanity.
I know, it's humbling.
It is, and a little bit scary, but also really exciting. We have this incredible opportunity to shape the future, and it's up to all of us to make sure we do it right.
I couldn't have said it better myself.
So, listener, that's a wrap on our deep dive into the world of ion superhighways. We covered a lot of ground, but there's still so much to explore. So keep asking those tough questions and stay engaged in this conversation because it's one that affects us all.
Yeah, this is just the beginning.
Thanks for joining us on this wild ride. Until next time, stay curious.